Oh man, we're already on video 4 of the brainstorming for treehouse designs. So in video 1, I went over the gist of some of the hardware for tree houses, a little bit of projects I've done with the metal conduit and other geodesic domes, and then looked at the geodesic spheres, the different types, and then zomes, the kind of other unique geometric shape. And then in video 2, I looked at the most simple form, the V1 of the geodesic sphere with equilateral triangles, and putting that in a tree model and getting the hardware modeled for the treehouse attachment bolts and actually putting them in the tree in the model and kind of seeing how they look installed in the tree and how we might actually attach this structure to those bolts. Just kind of a brainstorming of that. As we got into video 3, we actually got some of the conduit modeled around the structure and looked a little bit more closely at how this is going to attach to those bolts, the treehouse attachment bolts. And we got into a couple other details and things within each of these, kind of some tangents and unique ideas to consider. And I'm kind of going to do the same thing with this. I got a couple other things I want to kind of talk out loud about that I'm thinking about. And I've done these kind of quickly back to back. I'm in a particular space and time where I have some ability to focus on this and be able to play in these 3D models and on my laptop. I'm very soon going to be back working really hard on the property and hosting guests and really busy working the land. So while I have this brief moment to play with these designs and in the 3D software, I wanted to go ahead and get some things up so that people can start seeing what I'm thinking and help me brainstorm and come up with some other unique ideas here. So I'd love to hear your thoughts on what you think about this and where we could go from here. So with this video, with video 4, there's a couple things I want to cover. Let's see here. This guy is Charlie's Webs. He does these kind of like paracord woven structures in the trees. And it captivated me immediately. The second I saw this in my feed, I was just super impressed and like dug into it further, and it's super, super cool, which is really fun. So, but they're not cheap. It's super time consuming, and he would have to come out like to the property and spend a ton of time out here completing these. And because I started to look into that kind of cost and time and things, and at some point I really would love to have something like this to play with. But I was thinking maybe this could be included into some of these structures, which I think would be interesting. Let me play this briefly. I don't know if you guys are going to get the audio for it, but at least you can get a little bit of visuals of what's going on. I mean, it's super captivating. Very, very cool. This guy is spent countless hours in the trees and playing with these ropes, I'd imagine. And I think it's amazing what he's up to and doing. So thinking about some of this stuff, I think would be very cool. I know one of the things that immediately comes to mind is a little bit of concern about the strings kind of strangling the trees. And this, I was just thinking about this today, doing this kind of thing, but in the metal structure would prevent any issues of that strangling of the tree or whatnot. So somehow maybe weaving the idea of this into this structure, you could do a regular kind of roof over it, but then the floor and walls and things could be done in a similar way like this. So it's just an idea that crossed my mind, is kind of blending these, which I think would be really cool. He has a couple videos kind of showing how he does this. So I think I'll dig into that and see the practicality of it and what might be able to be done. But I think this is a cool base structure. And if you can get some kind of roof on it so you're out of the weather at least a little bit, and you weave your nets like this for the floor real tight, and then for the walls, you can be kind of cocooned in there. And it's kind of like a little play gym in the treetops. and then connecting these to other ones. So you kind of connect these and build bridges and tunnels between them. I think would be really interesting. He has some cool designs where he has built these into like a cylinder tunnel shape between trees. So they're kind of like a bridge. And I'm thinking maybe that can be done between like two of these or something. So that's going to be something I feel like I'm definitely going to explore further. I just really wanted to share that. I'll share links with everything I'm talking about in the description of the video as well, so you can dig in. I'd love to go play in some of these webs just for fun at some point. Hopefully I'll get a chance to do that. So I was thinking a little bit more about the treehouse attachment bolts and attaching this stuff. This is a really good read. I'll throw this in the description. This is a breakdown of the treehouse attachment bolts from Nelson Treehouse Supply when they actually got it tested at the university. It's pretty impressive. This is like a brand new facility at the university specifically made for testing bolts and hardware and stuff. And they worked the crap out of their hardware, their treehouse attachment bolts and cables and struts and everything. It's really, really cool. It just looks insanely impressive seeing what they have done and what these things are capable of. But yeah, so I'll share that link. And then let me show you. Well, let's just keep going down the line here. So this is showing the treehouse attachment bolt with a static connector connected with a beam to another tree that has the treehouse attachment bolt with a dynamic connector. That allows this to be rigid, and then this tree can move. So this is something, the more and more I'm thinking about this design, it's got me a little concerned about how much the tree is going to sway if you're looking down from the top, like the top moving back and forth, and what that would do to this structure, if it's going to be an issue or not. The big thing is a lot of the trees that I'm considering in a very specific area of my property are tulip poplar trees that are over 100 feet tall, just straight up. And the canopy is really high up too, the foliage on the trees and whatnot. So they have a ton of sway. I mean, those trees are just so tall and straight, and all their leaves are at the top. So I mean, I wouldn't have concern really. I feel like if I was putting this like a few feet off the ground, this bolt, the bottom bolt, but I am envisioning potentially putting some pretty high up to connect areas. So I'm starting to get a little concerned about like what kind of deflection we're going to get between these two points on the tree. And the more and more I dug into it, the kind of deeper that rabbit hole went. And I'll show you some of the research and paperwork on that I'm starting to kind of contemplate. So here's a look at their three main pieces of hardware. It's the tree fort bolt, the standard limb, and the heavy limb in rough dimensions. This is where it gets interesting. This is the capacities that they found when they did their testing at the Washington State University in that very specific testing center that they have there. So this is the tree fort bolt. This is the tree fort bolt with a cable. So it's where there's a cable attached from here, and then it's lagged into the tree up here. So that cable helps support that. And then there's the strut. So that's when there's an actual metal support that goes back this way down below. So those are the struts. And then it goes from the tree fort all the way up to the heavy limb. And you can see these loads are pretty crazy. You're looking at like 5,000 to 25,000 pounds on a single bolt. So that's promising. And I feel like you could build a really big cushion of safety within this, with these kind of numbers, if you're doing things properly, and have someone that's really cognizant of the trees and whatnot and understands them. Here's the static uplift arrestor so that this slides over the limb here. And I'm imagining that the bottom one would be this static one. So everything's kind of really rigid and attached right to that bolt. And then the top one here would have this dynamic ability. So as the swaying up above, it can kind of move around just a little bit. So we'll see with that. Let's see. And there's the tab. That's what the cable looks like, the suspension cable. And this is one of the dynamic attachments. So this tree can sway, but it can hold the weight of this beam. Here's what the strut looks like that would attach to the end and go down. Attach to the end of the bolt and go down to the tree. And then one more time, let's look at those capacities here. And again, I'll share all these links in the description. But that's pretty impressive. Pretty impressive. Okay, so I was just searching the web a little bit, and here's some of the stuff about the tree swaying. A little bit of details. So like when there's absent foliage, freezing temperatures, you deal with higher sway, slenderness and height of the crown to the crown of the tree. Some of the stuff is like kind of common sense, but it's like there's a lot of things to look at and consider, I feel like, and understand. So I don't know. I guess at some point I'll get into the nitty gritty and run some numbers with some of the equations that they're sharing for the hell of it. Wind sway and tree height measurement. So it talks like, this was cool. It just talks about like if the tree sways like 3 feet at the top, like how much are you looking at? Like a difference in like height from the top to the bottom and things like that. So yeah, I guess I'll dig into these. How trees sway and what it tells you about their overall vitality. Oh, that was interesting. Natural sway frequencies and dampening ratios of trees. And then there was this PDF I found as well. Estimating stem and root anchorage flexibility in trees. So the purpose of the paper is to highlight the fact that swaying of trees is affected not just by the bending curvature of the stems, so the actual trunk that's going up, like how much that kind of bends, but there's also stuff that happens at the root level where the roots are able to flex and bend and stuff too. So that they just open up my mind a little bit to really thinking about these trees at a deeper level. So I think this is making me really appreciate getting other engineer friends involved and a good arborist at this point. So yeah, that's that. What else we got? I think that kind of covers what was kind of on my mind a little bit. Thinking about the a little bit deeper level of what's going on with the hardware, the capacities. Charlie's webs just kind of popped in my mind. I was kind of brainstorming that. I think that could be neat. We'll get into the nitty gritty here of how we're going to get this all attached. This metal to this treehouse attachment bolt here. But I think that will do for this video. I'll see you guys in the next as we continue to develop this and make something cool. See you all.